All right, moving on to the next lesson, graphing linear equations. Now, ideally, when you are graphing linear equations, meaning equations that graph lines, you would like your equations to be in the form y equals mx plus b. Again, that is slope-intercept form, y equals mx plus b, where the slope of the line is the value of m, and the y-intercept, where the line crosses the y-axis, is going to be where the b value is. So again, knowing the slope and the y-intercept is going to make graphing your line much, much better. So looking at example number 1, we have a slope value of 2/3 and a y-intercept of positive 4. So graphing that line, we're going to first graph the y-intercept. So at positive 4 on the y-axis, we're going to put a dot because that's where the line crosses the y-axis. That's the y-intercept. Now all we need to do is find one other point here to graph this line, and we're going to use a slope to find that other point. So if you recall, slope is rise over run. So the number in the numerator is going to be our rise, and the number in the denominator is going to be the run. Since both are positive, we are going to rise up 2 and then run 3 to the right. So from our y-intercept point, we're going to go up 2 and then 1, 2, 3 to the right. There's our second point, which we can use now to go ahead and graph our line. So ideally, you should have a straight edge to go ahead and connect these points. And so I'm doing this freehand. And what's going to help also here is I can find other points here to the left. So I will do the opposite of rising 2 and running to the right 3 by going down 2 and to the left 3. And you can still see that, right, these other additional points are still collinear, meaning along the same line of the initial 2 points that I graphed. Okay, let's move on to example number 2. Again, we have a slope value here of -7/3 and our y-intercept of +2. And we're going to first graph our y-intercept of +2. And now we're going to go ahead and apply the slope value to find additional points to draw my line. And you notice that the negative symbol is like kind of in between the 7 and the 3. So you definitely want to make a decision here where you want to put that negative. Again, it really doesn't matter as long as it's, again, a place where you can easily find additional points for your graph. So I'm going to go ahead, I'm going to put that negative for my slope up with the 7. Okay, so there's my slope number. So that means my rise number is a -7. So I'm going to have to go down 7 and then to the right 3. All right, so down 7, 1, 2, 3, 4, 5, 6, 7. And to the right 3, 1, 2, 3. Put a dot. And there we go. There's my 2 points to make my line. All right. Moving on to example number 3. Now again, identifying those 2 pieces of information to help you graph your line. One of them is slope, and the other is y-intercept. So again, we're going to put our first point on the y-intercept. It's our b in y equals mx plus b. And now we're going to use our slope. Now you notice our slope here is not a fraction. And we want it to be a fraction, so we have both a rise and a run number to help us locate an additional point for my line. So again, what we can do here is we can easily make -3 a fraction by putting a 1 underneath it. Okay, so if your slope is not a fraction, right, you can make it a fraction by putting a 1 underneath. So now I have a rise number of -3 and a run number of +1. So down 3, 1, 2, 3, to the right 1, put a dot. Down 3, to the right 1, put a dot, right? I can go up 3 to the left 1 to get more points. So when I take my straight edge, I have enough dots here to go ahead and make my line as accurate as possible. Okay, so again, definitely you want to be using a straight edge when you're graphing your line. Now, sometimes your linear equation can be in forms other than slope-intercept. Like here, these next examples are going to be your linear equation in what's called standard form, where you're going to notice that the x and the y's are on the same side. Now, unfortunately, standard form does not give you the slope or the y-intercept as readily as slope-intercept form does. So what we need to do here is, before we graph this line, is that we want to change it into slope-intercept form. Okay, so we're going to change all our standard form equations into slope-intercept. So we're going to take this standard form and then we're going to solve for y. So we're going to subtract x from both sides. And then divide everything by 2. And when we do that, you're going to notice that now we have our equation in slope-intercept form. We see y equals mx plus b, where -1/2 is my slope and -4 is my y-intercept. All right, so again, when your equation is in standard form, you want to solve for y, which will get your equation in slope-intercept form. All right, so we're going to graph the y-intercept at -4, and then slope down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2. All right, so there's enough points here where we can accurately graph our line. All right, moving on to the next example. Again, we are looking at an equation in standard form, so we want to change that into slope-intercept. So we're going to subtract 5x from both sides first. And then to finally isolate the variable y, we're going to divide everything through by -3. All right, so as you can see, now that we have y isolated, we can identify our slope and our y-intercept. Now, because from the y-intercept of 4, I was unable to go up 5 and to the right 3, I did everything the opposite. So I went down 5 and to the left 3. All right, so that allowed me to be able to graph additional points here for my line. Okay, so when you're in a situation like this one where you have a y-intercept that's high up the y-axis and you're unable to go up and to stay within the graph grid, just remember, with a positive slope like this, you can just do the opposite for both the rise and the run. All right, okay, so that's it for this lesson. Let's go ahead and move on to the next video lesson.